In today's lesson, kita mau tengok dekat capacitors and then ask the question, what is the equivalent capacitance in series versus in parallel? Let's look at series first. Maybe I should draw a little bit more here. Let's draw 3 capacitor. So this is C1, C2, C3. If I ask you, what is the total current here? Atau the effective, not the effective current, but the current flowing in C1, C2, C3. The answer is, it's going to be the same, right? Obviously, that's the case because if current is flowing macam ni, say this is water kan, the amount of water that flows through C1 at certain time must be the same as C2, C3 because no other way kan? It's just one pathway, so the current must be the same. And knowing that I is equal to Q over T, we can say that I is proportional to Q. In that sense, because they are proportional, QT must equal to Q1, Q2, Q3, the same way as the current is like. What about voltage? Well, this is maximum voltage kan? Maximum voltage, and then they drop a little bit. Go here, drop a little bit more. Go here, drop a little bit more. Sampai dekat sini, the total voltage becomes 0. If this is 12 volt, this is plus 12V, then this becomes 0V below. Okay, so then voltage is the sum of the voltage drop across V1, V2, V3. Now, what is the formula again? We know that Q is equal to CV. This is by definition already lah. If we increase the voltage, basically if we increase the voltage, if we increase the voltage, the amount of charge on each plate will accumulate. So the higher the voltage, the higher the more the charge on each plate. So the constants are given by the capacitance. Right? So I can say then in this sense, my V is equal to Q over C, right? So I can rewrite this as Q1 over C1 plus Q2 over C2 plus Q3 over C3 is equal to the voltage drop. But then we know that Q1, Q2, Q3 is all the same, right? So I don't need to rewrite the subscript. Basically, no subscript because they are all the same. And then I can take out the Q and move it to the other side. So basically, VT over Q is equal to this addition. And we know that V over Q is what? Looking at this, if I have V over Q, Q over V is C, right? So V over Q is 1 over C. So here is 1 over C. Basically, our effective capacitance is the sum of the inverse capacitance in series. Okay, another way, a very simple way to look at this is from definition. Maybe I should not use pink, I should use different color. we know that from definition C is equal to the epsilon naught A over D, the capacitance, right? Meaning if we increase the area, the capacitance increases. If we decrease the distance, the capacitance increase. Okay. Effectively, kalau kita ada dekat series, what we are doing is the area is still the same, right? This is the area, but the length increases, right? Sebab daripada let's say D1 dekat sini, dia sekarang jadi D1 plus D2 plus D3. So in series kita cakap the total distance is kita tambah, right? So then I can write my effective ataupun equivalent capacitance should be this 1 plus 2 plus 3. Then I know that for if this is true, then C1 is equal to whatever this is D1, C2 is whatever this is D2, C3 is whatever this is D3, right? So if I were to inverse this, which is the same as taking this, which is the same as 1 over C1 plus 1 over C2 plus 1 over C3, kan? Sebab this is just the inverse of C. Make sense? Hopefully that makes sense. Now let's look at parallel capacitor. Parallel. So in parallel kita ada macam ni. So let's say this is C1, C2, C3. This is volt. In this case, what happened is, what happened to the voltage? Well, voltage drop is like the loop 1 voltage drop, loop 2 ada voltage drop, loop 3 ada voltage drop, right? But each voltage drop daripada 12 volt pergi 0 volt, let's say, daripada sini pergi sini, is the same as daripada sini pergi sini, because this is also from 12 volt pergi 0 volt. This is also from 12 volt pergi 0 volt, right? So then we say V total must equal to V1, V2, V3. What about the current? Current now have many choices, dia punya path, right? So basically, if I drew a water from here, water source I1, dari sini dia akan berpecah pergi sini dan sini, right? Then another dari sini pergi sini akan berpecah lagi, water source. Basically, the amount of water that flows from here are not the same. They are not the same. But when they meet together later on, daripada sini pergi sini, they meet together in this junction, kan? The total yang out akan sama dengan the total yang in. So I can say that I total is equal to I1 plus I2 plus I3. And obviously, because they are proportional to each other, I is proportional to Q, QT is equal to Q1 plus Q2 plus Q3. Alright. Now, we know that, again, Q sama dengan CV. We know this to be true. And so, Q1 is just C1 V1, Q2 is just C2 V2, and Q3 is just C3 V3, right? Now, knowing that the V total is the same, V1, V2, and V3 are the same, then I can pull dia punya V2 out, right? So cancel this. So QT over V is equal to C1 plus C2 plus C3. But what is Q over V? Q over V is just C, right? So Q equivalent is equal to that thing. This is how you derive. Then again, we have another way to derive this. We know that again, C by definition is this. Then, because if you look here, the distance doesn't change, right? The distance is always the same, D. We're not adding up the distance, but what we in fact adding up at certain time where the charge masuk ke dalam capacitance tu kan, we are essentially adding the area, right? Because if I were to sketch this, tambah mereka sama-sama, it will look something like ini tambah satu lagi 1, 2, 3. So the area makin panjang, but the distance is still the same. Similarly, kalau kita tengok dekat sini, kalau saya lukiskan 1, 2, 3, 4, basically that distance is going to be the same, but the area in which the electron doesn't go from here to here, okay? Electron go from here to here. But we're saying that the charge yang kumpul to the area is the same, but the distance is increasing. Hopefully that makes sense. Okay. In this case, then my area total is A1 plus A2 plus A3. So C equivalent will then be EOD. Let's bring this up because they're constant. A1 plus A2 plus A3, which is just the definition of C1 plus C2 plus C3, right? So yeah, we get another expression which is similar to this one. Okay.